You ever wonder how a truly great app gets built? It can feel like pure magic. But today, we're going to pull back the curtain on Apple's SwiftUI framework. And we're going to do it by thinking about something you probably already get: building with Lego.
I mean, you've seen apps like this, right? They just work. They look perfect on your iPhone, and then they adapt flawlessly to an iPad. It feels so smooth, so natural. But here's the thing. That polish, it's not an accident, not at all. It's actually the product of a really powerful design philosophy.
Slick, seamless, magical. Okay, but how? How does a developer actually go from a totally blank screen to that? What's the secret sauce that turns an idea into an interface that feels so alive? Well, that's exactly what we're going to get into.
All right, to really get it, we've got to dive into what makes an app tick. And it all starts with a huge shift in thinking, a totally different way to approach building a user interface. And you can see this shift laid out perfectly in Stanford's famous iOS course. They say, look, you're going to be using structs 99.9% of the time. It's a whole new ballgame, moving from what's called object-oriented programming to functional programming. Basically, instead of building with these complex, interconnected pieces, you're now using simple, predictable building blocks. And that changes everything about how you manage what's happening inside your app.
So what does that actually mean? Well, think of it this way. You're not writing a detailed recipe anymore. You're not saying first, draw a box here, next, put this text inside it, then color the box red. No. Instead, you're just describing a blueprint. You just say, hey, I want a red box with this text in it, and you let the system figure out how to make it happen.
And that right there, that's where our Lego analogy clicks into place. Describing a blueprint is exactly like snapping together digital Lego bricks.
Okay, so check this out. In SwiftUI, every single thing you see on screen is something called a view. That line of text, that's a view. An image, a view. Just think of each one as a single basic Lego brick. It's our most fundamental piece.
But you can't build anything cool with just one brick, right? You got to combine them. In SwiftUI, you use special container views to do that. You've got V-stacks, which stack your bricks vertically one on top of the other. H-stacks line them up horizontally, side by side. And Z-stacks, well, they layer them on top of each other, from back to front. It's how you build these really complex structures out of super simple pieces.
And this is where it gets really powerful. Just like the Stanford course says, once you put a few simple bricks together to make something more complex, like a rotor for a helicopter, that rotor now becomes its own Lego piece. It's a new, more complex, but totally reusable Lego. This idea of building bigger things from smaller things and then reusing those bigger things, that's the absolute key to building massive, complicated apps without it all turning into a huge mess.
Okay, so we've built our pretty Lego structure. That's our view. But an app isn't just a pretty face, right? It needs a brain. It needs to handle data and logic and all the smart stuff. So, how do we give it a brain without just creating a tangled-up ball of wires?
The secret is a really clean organizational system called Model View View Model, or MVVM for short. It's all about separating jobs. You have the model, which is the data, the view, which is what the user sees, and the view model, which is the go-between. The view only ever talks to the view model, and the view model is the only thing that talks to the model. This separation is what keeps everything neat and tidy.
So first up, you've got the model. This is your app's single source of truth. It's just the pure data and the rules. Think of a memory game. The model knows which cards exist and whether they're face up or face down. That's it. And the crucial part, the model has no idea what the user interface looks like. It doesn't care.
Then there's the view. And hey, we know this one. This is our Lego blueprint. Its only job is to look pretty. It displays whatever data it's handed, and it tells the system when the user does something like tapping a button. It's totally passive. It has no game logic, no brains of its own.
And connecting these two is the view model. This is the gatekeeper or the translator. It takes the raw data from the model and gets it ready for the view to show. And when you, the user, tap something on the view, that intent goes to the view model. The view model then figures out what to do and tells the model to update itself. It's this middleman that makes the whole system work so cleanly.
Okay, so having this clean setup enables one of SwiftUI's coolest tricks, a user interface that literally updates itself. It's reactive, and this is where we get to the really fun part, making it all look beautiful with super smooth animations.
Now, to really get animation in SwiftUI, you have to flip your thinking. This quote from the Stanford course just nails it. Animation is just showing you changes that have already happened. You're not creating motion from scratch. You're just showing a change in the data, but stretched out over a little bit of time. It's a huge mental shift.
So here's how it all plugs together. You tap a card. That action tells the view model, hey, flip this card. The view model then updates the model, changing that card's data from isFaceUp equals false to isFaceUp equals true. And here's the magic. SwiftUI sees that data changed, and it automatically redraws the screen to match the new reality. The UI is just a mirror reflecting the data. It's totally reactive. But, just having the card instantly appear face up can be a little jarring. So how do we make it beautiful? It's almost ridiculously simple. You just wrap that one line of code that changes the data inside a little block called with animation. That's it. That one command tells SwiftUI, hey, don't just snap to the new look, animate the change smoothly. And it handles all the complicated in-between steps for you.
All right, so that's the core philosophy. It's elegant, it's powerful, but how does all this classroom theory actually hold up when you're trying to get an app into the App Store? Because that journey, that introduces a whole new world of challenges.
Yeah, building an app is so much more than just writing code. It's a whole life cycle. It all starts with that spark, the idea. Then you build it. But then comes the really hard part, testing. You gotta squash bugs, make sure it's fast, make sure it doesn't drain the battery. Then you have to get through Apple's tough review process. And only then, after all that, do you finally get to launch it and hope people find it.
And those real-world hurdles are no joke. I mean, developers lose sleep over things like battery consumption because a power-hungry app is the first one people delete. Security is a massive concern. A breach can tank your reputation. And then there's the App Store itself. Apple's guidelines are famously strict. Or imagine you're not even selling to the public. We see this in forums all the time. Just trying to push an update to 1,500 corporate iPhones is a huge logistical nightmare.
What all of this really points to is that being a developer means you are on a never-ending learning curve. You're always solving problems. But the important thing to remember is, you're not doing it alone.
I love this quote from a student on Stack Overflow. They're basically saying, I can't believe I'm already stuck on the very first lecture. Everything was working, and then it wasn't. And that feeling, that is so universal. It doesn't matter if you're on day 1 or year 10. You are going to hit walls where things just break for no reason. The struggle is real, but so is the community that's there to help you figure it out.
So let's bring it all home. We've seen that building an app today isn't about writing a recipe. It's about designing a blueprint. The developer is becoming more like an architect, describing their vision and letting the system handle the heavy lifting of construction. And as that system gets smarter and smarter, with tools like AI becoming more integrated, it really makes you wonder, doesn't it? What kinds of incredible things will the digital architects of tomorrow be able to build?